Hi, today we are going to discuss about the hybridization. Hybridization is very important topic, especially in the pharmaceutical organic chemistry. If you understood this topic, it is very easy and very important also and easy to write also. But only the thing we have to be understand the concept. If we don't understand, it look very difficult. I hope next 15 minutes we are going to be enjoy together. Just see exactly what it is going to be happen in this case, especially hybridization. Hybridization means what? Hybridization is nothing but mixing of the pure orbitals, two or more than two. Remember this, two or more than two, mixing of the pure orbitals to produce the set of new equivalent orbitals. Equivalent orbitals means they are equivalent in the energy, they are equivalent in the shape. That's why this hybridization mainly helpful for the finding the geometry as well as the shape of that particular structure. That is the purpose we are using this one. For example, you might be take methane. It is having the tetrahedral shape. For example, you can take ethene, which is having the double bond. It is having the trigonal shape, that is called as a pyramidal shape. And you can take ethine, that is having the triple bond. It is having the linear shape. Like that means the based upon the hybridization, it is going to be change its geometry. But what I told about the hybridization, hybridization is nothing but mixing of two or more than two pure orbitals to produce set of new equivalent orbitals. A set of new equivalent orbitals. This process only we are calling as the hybridization. It means what here? Two or more than two pure orbitals. It means these orbitals, when you are mixing these orbitals, they are having the difference in the energy, as well as different in the shape. But after mixing, they producing the new equivalent orbital. Just remember this word, new equivalent orbital. Equivalent orbital means they are equal in energy and as well as the equal in shape. It means any molecule in the world, it is having the proper shape. Proper shape means proper geometry, proper structure, or you can say any molecule, if it is having the stable structure, it means what it indicate? It undergoes the hybridization. When it is underwent hybridization, then only it is going to be get the particular shape, proper shape. That's why we can say, especially when you will be take the different types of carbons, that may be methane, you might be take ethene, you can take propane, you take, they will be having the different shape. For example, you might be take the sp3 hybridization. sp3 hybridization, it will be having the tetragonal shape. sp2, it is having the trigonal shape. sp, they are having the linear shape. Means the structure or shape of the molecule, it is only due to the what? Hybridization. That is type of hybridization. I hope you might be understand what purpose we are using the hybridization. Only by the proper hybridization, it is going to give the perfect structure. Otherwise, nope. It is not going to give. Any molecule I am saying in the world. Then see, before going to the hybridization, we should know how to write the electronic configuration. If you don't know the electronic configuration, it is very difficult to find out how many electrons are there in outer shell, as well as another thing is that it is very difficult to understand the what type of hybridization it will be have, whether sp3, sp2 or sp. It means what? Hybridization classified into how many types? 3 types: sp3, sp2, sp. Sp means what? Here 1 s orbital and 3 p orbitals. Then 1 s 3 p. 1 s plus 3 p. Then how many set of equivalent orbital it is going to be produced? 3. That is sp3, 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 sp3. What is the definition? Mixing of pure orbital to produce the set of new equivalent orbital. This is very important. New equivalent orbital. 1s 3p mixed together, it given the equivalent orbital, they are having the similar energy, similar shape, sp3, 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 sp3. They will be having the tetragonal shape. But here initially s is different energy, p is different energy. Different energy means little difference is there. Don't think like that they will be having the huge difference. It is not like that. Very small difference is there. Then only they are going to be mixed together. There will be the large difference means it is very difficult to mix it together. It means they will be having the difference in the energy. What? Difference. Difference in energy. Very little. Very little or sometimes equal. Then only they are going to be produce the set of new equivalent orbitals. Total how many orbitals it is going to be produced? 4. Because here 1s and 3p. That's why it producing the 4 new equivalent orbitals. sp2 also similar. In that case also sp2. sp2 means what? 1s 2p. Then how many orbital, equivalent orbital going to be produced? 1 plus 2 means 3. 3 set of new equivalent orbitals, sp2, sp2, sp2. Here 4, here 3. Now go in case of sp, 1s, 1p. Then how many equivalent orbital it is going to be produced? Only 2. That is sp, sp. See, this is 4, this is 3, this is 2 new equivalent orbitals. 4 new equivalent orbitals, 3 new equivalent orbitals, 2 new equivalent orbitals. But another doubt will be get that I told that before discussing all this for finding out the hybridization, we should know that how to write the electronic configuration. For example, I will show you that. Carbon. Carbon atomic number is how much? 6. Now you can write the electronic configuration. 1s2, 2s2, in the s orbital only 2 electrons. Then 2p2. In case of p, 6 electrons can occupy. But how many are there here? See, 1s2, 2s2, 2p2. Then how you are going to find out this carbon? It is going to be produced the sp3 hybridization. How? How we are going to determine this? For that we have the formula. What formula we will be have here means Z is equal to, that is nothing but here it is the type of hybridization. Z is equal to valence electrons plus monovalent atoms, valence electron of the central atom, monovalent atom, divided by 2. What I told here, V is nothing but valence electrons of center atom. Center atom. Here, center atom means what? For example, you can take the CH4. Carbon is the center atom. Okay, center atom, valence electrons, how many? Then what I told, M is nothing but monovalent atoms. What? Monovalent atoms means here hydrogen, halogens. Remember these two, hydrogens and halogens, not other. Okay, done. Now see, I will take methane. Okay, methane center of the atom is the carbon. I wrote the electronic configuration. I put the square box here, you might be observing. These are the electrons. These are the electrons, they are present in the outer shell. It is belongs to the group 4. Carbon means, just check the periodic table, group 4. Group 4 means valence electron, it will be having the 4 in the outer shell. Okay. Now see, we'll apply the formula. Z is equal to valence electrons 2 plus 2, 4 in outer shell, plus how many monovalent atoms attached here? 4 hydrogens. Monovalent means what I told, hydrogens are halogens. Then how many hydrogens are there? Total 4. 4 divided by 2 is equal to 4. It means what? Total equivalent orbital, how many it is going to be produced? 4. 4 equivalent orbitals means what type of hybridization this one? sp3. Understand? Okay. For that what we required? Center atom, valence electrons plus monovalent atoms. Attach it to that center. For example, I will give another example. Another example we will take BF3. In case of BF3, this boron is there, no? This is the center of atom. Boron atomic number how much? 5. Then write the electronic configuration for boron. 1s2, then 2s2, then 2p1. Then total in the outer shell how many electrons are there? 3. How many? 3. Now I will write Z is equal to 3 plus how many monovalents are there? Monovalent means hydrogen or halogens, I told 3 divided by 2. What is the answer? 3. 3 means 3 orbitals it is going to be produced, means 3 equivalent orbital it is going to be produced, means what type of hybridization this one? See, 3 sp2. Understand what? sp2. Why it is going to be produced? 3 equivalent orbitals. How many Z is equal to how many equivalent orbitals it is going to be produced? That is based upon the valence electron and monovalent atom. It means in the examinations, competitive examinations, they will be asked any molecule. Easily you can find out what type of hybridization they have. What type of hybridization they have. For example, we can go for the another example. I think the length of the video will be going to increase, but no problem. Few people are there, good people like you. They will watch up to end. I hope so. Now see another one. PCl5. PCl5. Phosphorus. You know that phosphorus, center of the atom. How many valence electron it will be having in the outer shell means when you write the electronic configuration, you will come to know that is V is equal to 5 because it is belongs to the group fifth. Then how many halogens it will be have? 5. Then divided by 2. What answer will get? 5. It is neither sp3, neither sp2, neither sp. Then what it is? What it is? It is sp3d. What it is? sp3d. Understand? Okay. Right. Like this, we are going to be find out. Okay. We are going to be find out for any molecule, whatever it might be, whether it may be water, whether it may be carbon dioxide. You can take carbon dioxide, CO2, or you can take water, that is H2O. Okay, for any. For example, you take the water, H2O. Oxygen is the center of the atom. Oxygen having the total valence electrons are 6 in the outer shell, right? 1s2, 2s2, then what? 2p4 because oxygen atomic number is 8. Now see how many electrons are there in outer shell? 6 because it is belongs to the group 6. Z is equal to 6 plus how many hydrogens are there? 2 divided by 2. Then what is the answer? 4. 4 means what hybridization? sp3 because 1s 3p. Total 4 equivalent orbital it is going to be produced in the sp3. Like that you can take for the carbon dioxide. Any molecule you can choose. Any molecule you can write. Then damn sure you are going to be find out the type of hybridization. What type of hybridization they are having. Okay. I hope you might be understood this. Understood or not? Okay, just take down. Just calculate like that. Then you are going to be get the type of hybridization. What type of hybridization they are having. Okay. Only the thing is that we have to choose the center of atom. Then we have to find out the valence electrons. How many valence electrons are present? Then easily it is going to be given. Now we'll go for the one by one. Okay. Hybridization. Then we'll go for the carbon first. Atomic number 6. Example you can take methane. We are going to find out the sp3 hybridization for the methane. How it is having the sp3 hybridization we are going to be find. Okay, because atomic number for the carbon is what? 6. Then we want to write the electronic configuration. What it comes? 1s2, 2s2, 2p2. Okay. Outer shell 4 electrons are there, valence electrons. Okay, then 4 plus 4 divided by 2, 4. It means it is going to be give the sp3 hybridization. How we can write the sp3 hybridization if they will be asked in the examination? I will tell you now. First we will be take the ground state. They are different. Any molecule you might be take, ground state behavior is different, excited state it is different, hybridized state it is different. Excited state means some energy they might be get, they are exciting from the one state to the another state. Okay, it is happens. If as a human being will get energy, we will also go from the one state to the another state. Is it right or not? After all, these are the molecules. Now see 1s2 that is 1s. In case of 1s, how many electrons? 2 electrons. Okay, opposite spin. Now see, 2s. 2s also how many electrons? 2 electrons. Then see, 2p. How many electrons according to electronic configuration? How many electrons? P means how many orbitals? 3 orbitals. Okay. This is called as the px. This is called as the py. This is pz. P orbital means each orbital having the 2 electrons means 3 orbitals. Capacity is 6 electrons for the p orbital. Now here how many electrons are there? Just see, 1, 1, 2. Only 2 electrons in the ground state. Now we'll go for the excited state. Again 1s, same. Then 2s. Here we have to be observed in the excited state, it is going to be excite. Then that electron will be going to be shift to the p orbitals. Remember that what I told. This is px, this is py, this is pz. Okay. Now you can see all orbitals it is going to be filled with one electron. Px, py, pz. Okay, because here one electron it is jumped. One of the electron it is jumping in the excited state here. That's why it is going to be fill the pz orbital. Now hybridized state. This state is very important, hybridized. See, hybridized state 1s will be remaining same, 2 electrons. Now you can see here it will be undergoes mixing of these two, 1s and 3p. How many p orbitals? 1, 2, 3. S is 1. They are mixing together to produce what? sp3, 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 sp3. What I told? In case of particularly hybridized state, mixing of this 1 s orbital and 3 p orbital, 1s of the 2s. Okay, 1s and 3p orbitals to produce how many? 4 set of new equivalent orbitals. sp3, 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 sp3. How it will be? Example, you can take the example, general example. Okay, here you can see, yes, this yes is nothing but, you might be think like that, you will be like non-veg, I think so. Is it? Non-veg, we will take non-veg means just here. These are having the veg. All they are having the veg, but here it is having the non-veg. Then what it will be do? This veg and non-veg, they are sharing together. 4 friends. 1, 2, 3, 4. How many friends? Total 4 friends are there. I will indicate with this mark. It is easy. How many friends are there? 1, 2, 3, 4. Total 4 friends are there. They are sharing. What they are sharing? They are sharing non-veg with the veg. Non-veg with the veg, it will be look very tasty. Yummy taste. Is it right or not? Then they are sharing together. Then after sharing, after going into the stomach, same shape, veg, non-veg. Other example you might be take. Here they are having the chocolate ice cream. What ice cream? Chocolate. They are having the pineapple flavor. Chocolate and pineapple flavor. They are mixing together all. Chocolate, small amount of chocolate and pineapple. Chocolate, pineapple. Chocolate, pineapple. Chocolate, pineapple. Mixing together. Okay, to give the equivalent energy and equivalent shape. means equivalent taste. Equivalent energy means equivalent taste. When they are not mixing, chocolate eating different, vanilla ice cream eating different. Taste will be different. These three persons feeling different taste. This person also feeling different taste. But when they mix it together, when they are sharing four friends together, they are going to get the same type of taste. How it will be, you can see. This is the S. Okay. This is the P. 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 This is the vanilla flavor. You might be thinking black chocolate flavor. After when they will be going the hybridization, what happened? What happened there? All they are mixing together. All they are mixing together means, see, chocolate, vanilla, chocolate, vanilla, chocolate, vanilla, chocolate, vanilla. Here, vanilla is different, chocolate is different. That's why taste is different. When they are mixing together, yummy, yummy. Is it right or not? Here also same. That is the reason after mixing they are going to produce the equivalent orbitals. How many? 4 equivalent orbitals. That's why from tomorrow onwards, whatever you are bringing in the lunch box, remember, share with your friends, because where belongs to the sp3 hybridization. Okay, we have to share, then we will get the equal taste. Okay, understand? This sp3 hybridization, especially we are observing in what? sp3 hybridization, this one. Where we are observing this one? We are observing in the methane CH4. Already I shown the calculation how we are going to be calculate how many hybridized orbital it is going to be produced. Okay, then see sp3 CH4. Now how we can write the orbital structure for this one? See, this, you can see here, hydrogen, 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 H, 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 H. Then see what shape it is going to be get now. Draw. See what type of shape it is called? Tetragonal or tetrahedral. Tetrahedral, whenever in between the carbon and hydrogen, see, like this. Okay, hydrogen, the bond angle always 109 degree. You might be studied in case of Beer-Strain theory. What is the normal tetrahedral angle? 109 degrees. How much? 109. Understood? I hope so. Okay, like that we are going to be do the sp3 hybridization. See, in this case sp2 hybridization. sp2 hybridization means it is not for the methane, it is for the ethene. sp2, that is, what is the structure of the ethene? CH2, 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 CH2. See, this carbon, what hybridization it will be have? This carbon, what hybridization will be have? Generally, we have to remember that single bond sp3, double bond sp2, triple bond sp. Understand? Repeat once again. Single bond sp3, double bond sp2, triple bond sp. But how you are going to be find out? In the examination you might be know, it is very difficult to identify. That's why again we have to follow the same formula. Z is equal to V plus M by 2. Then what it will be give? For example, this is the center carbon. Center carbon valence electron how much? 4. Then how many monovalent atom it will be have? 2. Then divided by 2. How much it will be give? 3. 3 means what? 1s, 2p. Total 3 orbitals. sp3. This is sorry, sp2, 1s 2p. Then this is sp2 and this is also sp2. Means in the double bonded compound we are finding the sp2 hybridization. How it will be, how you will be write in the examination? Okay, you came to know it is the sp2 hybridization, especially in the molecule like ethene. We understood that CH2 CH2. For this ground state, excited state remains same. Remember that. For all, sp3 also, sp2 also, sp also. What it will be changed? Hybridized state. In that also 1s will be remain same. But in case of 2s, you can see here. In this state, what will be happen here means, in the hybridized state, you might be observing here px, py, pz. This is 2s. Okay. Now what happens exactly means, all these three, one from the 2s and two from the px and py, they are mixing together. See here, 1 1 1. What is this? sp2 sp2 sp2. It means 1s and 2p. Then it is giving 3 equivalent orbitals. Remember that. How many they are mixing together orbital? That many equivalent it will be produced. 3 means 3 equivalent. Previously 4 in the sp3, 4 equivalent. Now 3 equivalent, sp2 sp2 sp2. But this one remain unhybridized. Which one? pz. Okay. All these people, they mix, they are shared together. They mix it together. Yes, px and py. That's why they given the sp2 sp2 sp2. They share vanilla, chocolate, both the flavors. But this person pz is saying, no, I don't share. I like vanilla only. I don't like chocolate. Vanilla means not the girl. Remember that. Okay, flavor. I like only the vanilla. I don't like chocolate. Who like chocolate? Please go. That's why here 2p and 1s mixed to produce the 3 equivalent sp2 orbitals. That's why it is called as the sp2 hybridization. Understand? Then what s character it will be have here means, sp2 s character is 33%, p character is 67%. In case of sp3, I forgot to tell you there, in case of sp3, 25% s character, then 75% p characters. P is 3 parts, that's why 75. S is 1 part, 25. But here you can see P is 2 part, S is 1 part, 33, 67. S character will be here increased. Another logic is there, I will tell you at the end. S character increases, what will be changed? Okay, this is about the sp2. Now you can go for the sp hybridization. In case of sp hybridization, sp, 1s and 1p. What is the sp and character? 50% s character, 50% p character, because half. Now see, here what it will be saying, here another 2% they dropped. Py, pz, what they are saying? I like only vanilla, we don't like chocolate. Then px it's saying, no, I like chocolate. Chocolate it like means px means it have to be go with the 2s. Is it right or not? That's why one of the p orbital mixing with the one of the s orbital of the 2s. Okay, that's why what it is going to be produced here. Remember this, at the hybridized state, it is producing 2 equivalent orbitals, sp, sp. They are mixing together both. That's why it's producing the sp. How many? 2 equivalent orbitals. Then here, how many unhybridized orbital will be remain here? See, how many unhybridized? They are saying we like only vanilla, we don't want chocolate, that's why not mixing with the S. They remain same. Here only unhybridized PYPZ. This is called as the unhybridized p orbital. Previously I given the example what for sp2. The shape I told different. sp2 shape is different, sp shape is different. See, when you will be write the ethene structure, orbital structure, the ethene, see here, how many unhybridized orbital in case of sp2? One unhybridized orbital. See how many? One. That's why you can see here, this is the sigma, this is the pi. Half pi bond is upper side, half pi bond is downside. This is the unhybridized pz. Here also pz. That's why what type of hybridization this one? sp2, sp2. That's why you can see the shape of this one. What shape it is going to be get? It is going to be get the shape of trigonal. This shape, trigonal shape. What shape it is going to be get? Trigonal shape it is going to be get. But in case of sp3, tetragonal. How it will be? This is trigonal, but in case of sp3, tetragonal, like this. That's why bond angle is 109. But here in this case, the bond angle in case of trigonal is 120 degree. See the bond angle 120 degree. But in case of sp means what example? Ethylene triple bond. You can apply the formula for this one also. Okay, when you apply the formula CH means Z is equal to C, carbon valence electrons 4, then how many monovalent? 1 divided by 2, how much it will become? 2.5 around. 2.5 around means we are going to get how much? What hybridization? 2 equivalent orbital. It is equal to 2 equivalent orbital. 2 equivalent orbital means it is sp hybridization. Okay, now see the geometry, the structure. Okay, tetragonal in case of sp3, trigonal in case of sp2. Okay, then in case of sp, how you will be write the orbital structure for sb? Just see here how I am going to write the orbital structure for the sp. Sp means what example I given? Unhybridized orbital, how many? 2. 5 orbital overlapping, side to side overlap. Upper side is 2 halves, downside is 2 half. Total how many? 2 bonds, means triple bond. 2 pi bonds, 1 sigma bond. 2 pi bonds, 1 is the sigma bond. Okay, that's why it is triple bonded molecule. Triple bonded molecule means you can see the geometry of this one. What geometry? Don't consider to the pi, just consider to this one only. Then what shape you are going to be get here? This is called as the linear shape. What is the bond angle? 180 degree. See, in case of sp2, how much? 120. Is it right? sp2 how you will write? Only one unhybridized p orbital is there in that case. Is it right? Hydrogen, 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 because this is the structure of CH2 double bond CH2, CH2, CH2. Then how many unhybridized? In case of sp2 already I shown 1. In this carbon also 1. Is it right or not? Yeah. See, now see the shape of this one. Don't consider this unhybridized orbital. Consider this. What shape it is going to be get? See what shape it is going to be get. This is called as the trigonal. This is called as the linear. Okay, in case of sp3, already I shown 109 degree. What shape? Tetra. Here the band angle is how much between this? Here band angle is how much I told? 120 degree. In case of sp2, in case of sp, bond angle is 180. Is it right? In case of sp3, bond angle is 109. I hope you might be understand this hybridization. Okay, now I will tell you what happened with the, we saw the structural difference. Now I will tell you what bond length difference they will be have. Bond length sp3, in between the sp3 the bond length will be the 1.54 angstrom. sp2 1.34 angstrom. sp 1.20 angstrom. See, in case of sp3, S character is 25%. Here S character is how much? 33%. Here S character is 50%. What happened here? Bond length, what happened? What about the bond length? Bond length decreases. Bond length decreases. Why they are decreases? Okay, bond length decreased. See here, bond length decrease. Why? Percentage of S character increase. S character increase means bond length decreases. See, S character 25, 1.54, 33, 1.34 decrease, 50, 1.20. Means bond length, it is going to be decreased by increasing the S character. That's why sp hybridization bond length is different, sp2 bond length is different, sp3 bond length is different. Not only the bond angle, even bond length also different. I hope you might be understood the hybridization. Okay, thank you very much. We'll meet in the next class. I'm going to share the notes in the telegram link available in the description. Okay, thank you.